A non-stop self-driving car that can solve traffic problems. All vehicles are automatically driven, and when the vehicle departs, they are controlled by the system. The number of people transported per hour is 160,000, 3 times that of subways. It runs ultra-high speed in the city center. Vehicles as a technology that can drive at non-stop 162 km per hour. High speed in the city. The dedicated passageway to be built in the center of a large city is in the form of a tunnel, and there are few obstacles due to the closed top, bottom, left, and right. So autonomous vehicles with 4 stages of autonomous driving are operated at non-stop high speed. Thousands of self-driving cars travel at non-stop 162 km per hour speed, transporting more than 100,000 people per hour on the dedicated passageway in the city center and commercializing self-driving cars. Non-stop 162 km per hour in the city center. Instead of the subway, a 2-story highway is built in the city center. Place the crossing directions on the upper and lower floors, respectively. In the city center, non-stop high-speed driving will be carried out at high frequencies. Cars that used to run at high frequency diverge to the branch line, stop and get on and off. Passengers get on the parallel platform and depart sequentially. Cars departing from the distributed terminal gather on the main line and operate at high frequencies. The large interchange of the highway occupies a large site and cannot be installed in the city center. But the structure that is easy to turn left allows a large turning radius of the connection road. And the BD of the 2-story road can reduce the interchange by more than 20 times, enabling urban installation. This he installs a diamond-shaped intersection that fits perfectly into the intersection of the city center. Along the wide road in the city center of a large city, a 2-story road with many intersections is built as an elevated or underground road. Interchange with a large turning radius enables non-stop high-speed driving in the city center. Unlike subways, there is no subway station on the main line road, so non-stop high-speed running is possible. After high-speed driving, stop and get on and off at the terminal installed at the end of the branch line connected to the interchange, such as a highway. Self-driving cars arriving at their destination stop and get on and off the platform of the terminal. Self-driving cars on the road cannot drive at high speeds in the city center, but they can safely drive at high speeds on BD's 2-story road. All cars are autonomous without a driver and are controlled by the system when the vehicle departs. Up to 5 passengers with the same destination will join. Unlike highways, BD has a vertical crossing direction, reducing the installation area by half, and the entire section consists of one-way. Subway or light rail runs only less than 30 times per hour, so transportation is insufficient and efficiency is low. Unlike subways and light subways, 2-story roads can operate at high frequencies, and several lanes are installed to provide high-capacity transportation. The lower floor of the 2-story road branches off by a branch line, and the upper floor shows a structure of gathering from the branch line. Cars starting from numerous terminals on several branch lines enable high-frequency operation. Cars travel at constant speeds and intervals on a one-way road that is sealed up, down, left, and right like a tunnel and has few obstacles. Cars drive non-stop high speed as stably as on a highway. In addition, since the straight road is good and the turning radius of the connection ramp is large, it can travel at 162 km per hour, and then it moves 45 meters per second. The number of terminals or vehicles can be increased or decreased from time to time during operation, and double-decker roads can be extended and connected continuously. The big advantage of self-driving cars is that the distance between cars can be narrowed to a minimum because the not responding distance is short in the event of an accident and braking is possible immediately. Self-driving cars will travel at regular intervals and speeds to have the best ride, and all passengers can move comfortably and refreshingly as they will be given seats. All cars that used to run at high frequencies decelerate after branching to the branch, stopping at the destination terminal, getting on and off, and returning to the main line. When the car stops at the platform of the terminal, the screen doors and car doors open, the passenger gets off, and the cars depart for the next destination with the passenger on board, or empty car. This two-story road is connected by three-dimensional intersection with other routes, can be extended continuously, and moves non-stop anywhere like a highway. Continuous extension and expansion will eventually connect the entire city and all nearby cities. This two-story road is preferentially installed in downtown areas of large cities with heavy traffic. It is recommended to build underground instead of subways, but elevated installations are possible, and elevated installations save money, and period. The two-story road overcomes the disadvantages of accessibility and large interchange site, which are the disadvantages of highways, and specializes in urban installation. Cars driving at constant speeds and intervals are too stable and relaxed. Safety partitions are installed between lanes, and the top, bottom, left, and right are sealed, so there are few factors that interfere with driving within a two-story road, such as a tunnel. And the only obstacle is the front car in real-time communication. Cars in the opposite direction are always driving downstairs. This two-story road is built in the center of a wide road in the city center, built on it, or underground. If branching on the lower floor of the double-decker road, it merges on the upper floor. And the more branch paths there are, the greater the usefulness. The branch stop method improves the shortcomings of railroads or track methods that operate at extremely low frequencies of less than 30 vehicles per hour to stop at the stations, and is already driving high speed and high frequency through such a structure on highways. Cars to stop and cars to drive at high speed are divided through interchange, and cars branching to their respective destination terminals to stop. And passengers get off or get on. The terminal has several platforms arranged in parallel towards the main line. So cars entering in succession stop sequentially and can also start continuously. The cars change direction in the U-turn area and gone back to the main line through the upper or lower floors of the road. Terminals are installed mainly in places with high traffic, and separate stations can be built, but they are small in size and are likely to be installed in underground parking lots of large buildings. And terminals can freely select size, location, and installation timing. In particular, terminals will also be installed in apartment complexes and the value of apartments, buildings. Almost all buildings in the city center can be connected to new transit by sharing terminals through interconnection pathways. The interchange has a large radius of rotation while being properly connected in all directions through cross-linked ramps. This intersection design is easy to install in a cramped city center by reducing the size of the intersection. The new transit system can also be implemented rapidly and inexpensively without tunnel excavation by converting the existing subway system. When traffic difficulties are resolved, cities are dynamically energetic and develop greatly, and so will countries and individuals. High-frequency operation enables high capacity and high efficiency. High capacity and high efficiency are also possible with high profits and low fares, enabling a virtuous cycle of mass transportation.